Yeah, all instruments is my voice is loud and clear. Okay, done. So in the last class, we are discussing about the text data, right? So let us complete the text data today. Uh, yeah, Dilip, you have to tell me why today less number of students. I am also wondering the same. Uh, Video not uploaded. Yeah, I have not received the video. Once I receive it, I will upload. I asked the team to share. Most probably in the next few minutes, I will receive. Once I receive it, I will share. You can. Okay. Done. So now in the last class, we have seen the how the model works for the test classification project and how it is going to predict for the future data, right? Now, before sharing to the model, as I've told you, for test classification projects, we have to do some kind of cleaning. And that type of cleaning, we call it as text cleaning. So in today's class, we are going to see that how we are going to do the text cleaning for the test classification projects. So this type of cleaning, what are the cleaning I have told you? That is remove the punctuation marks, remove the stop quotes, and all these things. Whatever I have told you from here to here, everything is only for the text classification project. Okay, way a text classification project or text clustering project also for non-sequential data. Non-sequential. Here, sequential order is not important. Okay, right? So here it is a non-sequential data. So since it is a non-sequential data, okay, so we are for all the non-sequential data, this kind of things are required. Done. Next, coming to the next one. Okay, so here tokenization and next remove the punctuation marks, stop quotes, stemming and lambdization and vectorization. So first, as I've told you, first in the previous class, we have to do the cleaning. That is nothing but first I'm going to import the NLTK and here I'm going to take he is a good boy, she is a good girl, boy, girl are good, right? Now, next, as I've told you, tokenization means nothing but breaking into the sentence or breaking into the words. Now, what is meant by stop words? Stop words means the words which are not having any importance. The words which are not having any importance. Those words are called as stop words. So these without this word, for example, uh, I'm writing here, okay, in the Google, um, within the Google, just I'm typing here, what is the temperature today at Hyderabad? What is the today's temperature at Hyderabad? Okay, today temperature or current temperature at Hyderabad. Okay, something I'm typing here. And here I'm getting the output as 24 degrees centigrade and it is 6 p.m. and it is clear. Okay, something. I have got the information. Okay, what are the information I have received here? Here, what is the current temperature at Hyderabad? This is the point which I have typed here. Now here I'm removing the. Okay, without the, just I'm typing what is the current temperature at Hyderabad. Still it is giving the same answer. There is no difference. Same 24 degrees centigrade, same it is clear, everything is same. Now I'm removing the is. What current temperature at Hyderabad? Still the answer remains same. It is 24 degrees centigrade. Now, if I ask by removing the at, what current temperature Hyderabad? Still the answer remains same. That is 24 degrees centigrade. And it is showing the same output. Everything is same. Now I'm removing the what also. Current temperature, Hyderabad. Still, the answer is same. Now, what is the at? These four words, what are the four words are there? These four words are not having any sense. Sir, they are not having any sense, miss. Then why are you going to use, miss? They are using for the grammar purpose, for communication purpose. Okay, the English grammar, whatever was created, the English syntax, it is purely for the communication purpose. If you want to communicate, when you want to communicate with others, then what are the syntax you are using, others are using of the same syntax, then both can discuss each other, because whatever you are saying, others will understand. For example, that person don't know what is the syntax, English syntax, he don't know. You are using the English words or English sentence formation and high level English and with perfect grammar, everything you are using also. Other person don't know anything the syntax means, it would be difficult for them to understand. Right? Now, when you know the some English syntax, you also know, other person also knows perfect English syntax means, then a good grammar between both of you will help for the good communication. So the languages are created only for communication purpose, nothing else. Right. Now, what are the languages are created for communication purpose? Here, some words will not have the any importance for the test classification. As we know in the last class, how the test classification works. In that each word along with their probability. What are the probabilities there? The probability will be calculated, and the probability more number of times it was repeated in the inbox means it will be inbox. If the more number of times it was repeated in the spam means spam. So purely it depends on the probability, individual word wise. In that individual word, it doesn't consist of what words are there, which sentence is there. It doesn't focus on the sentence. Words are only important. How many words are there and what is the probability of each word only. Whether you have written SRK is a good trainer, whether you have written SRK is a bad trainer also, SRK is SRK only for them. Is a bad trainer, nothing will be considered. Point is clear? Now, so here we are having the some list of stop words. These words are not having any importance. They are used only for grammar purpose to create a proper sentence. Otherwise, they are not having any importance. Sir, for test classification project, it is not important. But when it comes to the chat GPT, in the chat GPT, when I'm asking some question, it is giving with a proper English grammar, no sir, miss, that is sequential data. For non-sequential data, it is not important. For sequential data, stop words are also important. That is different. Right? Next, coming to the next one is called as stemming and lemmatization. Now, what is meant by stemming and lemmatization? Stemming means the word stemming or lemmatization, both of them will bring the given word to the base word. For example, let's take an example like this. You are having the some word called as some word we are having the beautifully, okay, and beautiful, beauty. These are the words. Okay, assume these are the words are there. Three different words are there. Meaning is same. One is adverb, one is adjective, one is verb. So if you go to a particular place, we are going to say it's a beautiful place. In that case, we are going to use as a adjective. In some cases, beauty, where we are going to use the word as the verb in some sentences. But these three of them will have the same meaning. Right? Like as we are having the different forms of verb, different forms of noun, but they are also having the same meaning. Right? So here, whatever the words are there, instead of having the words like this, because now I'm going to cut to the base word, means beautifully also will be cut to the beauty. This one also will be cut to the beauty. This one also will cut to the beauty. Sir, why we have to bring to the base word? Why? What is the reason behind this? Miss? Very simple. For example, if you consider the male, in the male, multiple words will be there. So how many words are there? If for one word we have to calculate the probability, miss, multiple words will come. The data will be very huge. How to reduce the size of the data? That is the question they have got. How to reduce the size of the data? Okay, by keeping the same accuracy. Accuracy should be same, but the number of words has to be limited. We have to reduce the words. For example, beautiful word was used in the spam for multiple times. Beautiful word was used in the spam for multiple times. Beautiful word was used in the spam for multiple times, means high probability is there. At the same time, beautifully is there. Beautifully word was used in the inbox for multiple times. Now, assume this was used for 20 times. In the inbox, this was used for 2000 times. Now I've got a new mail. In that new mail, it's a beautiful place. Some beautiful place word is there. Now, beautiful was there. Now, though it is spam, multiple times it was repeated, or let us take as inbox. In inbox, 2000 is there. In the spam, 20 only is there. Let's take like this. Beautiful word in the inbox, 2000 is there. But according to this, inbox doesn't consist of even one word also, but spam only consists of 20 words. Now, whether it will be considered in the inbox or it should be considered in the spam is, if exclusively if you are saying only beautiful word perfectly, only beautiful word, then automatically this will comes under spam. But if you combine these two, overall if you combine, that is beautifully and beautiful both are having the same meaning only. Based on the grammar wise, we are going to use that word before or after, okay, as a verb or adverb. If you understand that logic means, then in that case, these both will be considered as one word. So to bring to the base word, here we are going to use the stemming. So nltk.stem, I'm going to import to the Potter stemmer. And this Potter stemmer.stem, stem is cut to the base word. So here it is going to cut to the base word and I'm going to get the output as like this. So that word is not having meaning, no sir. In the stemming, the output of the stemming may or may not have the meaning. That is the difference between the stemming versus lemmatization. The same word, if you are using in the lemmatization, what are the same word you are using in the lemmatization? See here, it is taking time to give the output. It is taking time. Why? Because it is identifying the correct nearest word in the English dictionary. Meaningful word. So whenever you are asking the lemmatization, comparatively it will take more time. That is first minus point in the lemmatization. Second, it is going to give the meaningful word. Sir, now meaningful word is important or not important? Means this is the most important point. Okay, and this is one of the interview question within the text, the base question of text data. What is the difference between stemming versus lemmatization? Okay, stemming versus lemmatization. What is the difference between these two? Stemming versus lemmatization. Right? Now, so in the stemming and lemmatization, both of them, the common point is, in both of them, the common point is the cut to the base word. What are the given word is there? The given word will be brought to the base word, cut to base word. But this one also will do the same. This one also will do the same, cut to base word. Okay. Next, second, in the both of them, second, what is the main difference in both of them is output is, what are the output of the base word? Output base word. The base word may or may not have the meaning. May or may not have meaning. So whereas lemmatization, the base word, what are the base word is there? The base word will have the meaning. Okay, have meaning. The base word have meaning. Okay, but it may or may not have the meaning, right? Now, next, where we are going to use stemming and lemmatization means when there is application. The application of this is where there is no human interaction. Means the system will do automatically everything. Means then stemming. Now the application of this, where we are going to use this one means where there is human interaction. Okay, where there is some kind of human interaction. What is meant by human interaction? Interaction means discussion. Two people are discussing, it is called as interaction. So now, for example, if let's take an example like this. Nowadays, we are getting the ACs and everything by inbuilt Alexa or Google Assistant or something, right? Now assume that AC is having the inbuilt Google Assistant or Alexa, right? Now, just I asked the Google Assistant to switch off the AC. In the AC remote, just I told that switch off the AC. Now it has switched off. Now in this, in the backend, stemming will be there or lemmatization will be there. Stemming or lemmatization? Anyone? As per this, what I have told you just now. Yeah, it is stemming. It is not lemmatization. No, guys. It is stemming. It is stemming. It is not lemmatization. Why? The reason is, for example, you are asking your Google Assistant. Google Assistant up to here common. But this Google Assistant, where it was installed? In the AC. Okay. In the AC, I told you clearly. Switch off the AC. Now the Google Assistant, whatever was integrated inside that, simply it was switched off. Done. But there is no interaction now. It is not going to say that, okay, SRK, since you asked me to switch off the AC, I'm switching off. It is not going to speak to me, right? It is not having any speaker or it is not having any kind of video output. Speaker is not there or video output is not there or audio is not there. Just it is taking my words only, but it is not giving the reply for me. When there is no reply from that, automatically it is stemming. In your mobile phone, Google Assistant, in your mobile phone, Google Assistant is there. Same Google Assistant is available in the mobile phone. Now in the mobile phone, what are the Google Assistant is there? This is lemmatization. Understood? Because the Google Assistant is going to give the output and we have to see that output. Or it will say outside. Point is clear? Yes or no? Interaction means back we have to get the reply. When there is no reply, it is not called as interaction. Only instruction. Exactly. Only instruction. For instruction cases, go with the stemming. For instruction cases, go with the lemmatization. Is the point is clear? Yes or no? Now, let us take one more example like this. For example, you are having the Alexa speaker, Amazon speakers, we are having an Alexa. Now, I asked my Alexa, play my favorite songs. Now, do you think that Alexa will give some output? I mean, Alexa will say that, okay, SRK, I'm playing your favorite songs from this particular movie or something. It is going to say like that and it will play the song, or it will not do, it will not speak to me directly, it will play the song. So, for example, if I ask my Alexa today, okay, it will respond, right? So, for example, incorrect, if you have given any incorrect input also, it will respond. For example, if I'm asking what is the today's news, miss? whether it will give the output or not. At least it will show on the screen something. For example, if I ask in the Google only, Google Assistant is there. If I ask what is the today's news, it is going to show me right on the screen. So whatever it is showing me on the screen, I have to read. I have to read means I have to understand. So meaningful words should be there, or non-meaningful words should be there on the screen. So meaningful words should be there. So meaningful words should be there means obviously we have to use the lemmatization. Okay. So for example, now tell me guys, finally, but Google, I have sent one mail to you. In the backend, it is doing something. And finally, you are going to receive in the inbox or spam. Now tell me, according to you, in the Gmail backend, stemming is there or lemmatization is there? Tell me guys. Nagarjuna, stemming. Sai, stemming. Mayur, Jahanavi, stem. Still, only 3 students are. Shanti, stem. Okay. Dharmendra, lemmatization. Okay. Still. Guys, only 4 to 5 students. Right? So now some of the students and majority of the students are saying it is stemming. Some of the students are saying it is lemmatization. Now tell me guys, okay? Now here I have sent one mail. Okay, tomorrow we have ML class at 6 p.m. Go through previous class once. What are the previous classes there? Go through the previous ML class once before attending. Okay, this is the mail which I have sent from my end. And you have received from your end. This is you and this is me. I have sent and you have received this. As it is the same thing. Maybe either in the inbox or in the spam. Something you have received. Okay, as it is you have received. There is no difference. It is neither converted or anything. But in the backend, classification will be done. Whether to share in the inbox or in the spam, classification will be done. Now, in that, any human interaction is there? I mean, in the backend, any human interaction? Hello? Right? Understood, guys? In the backend, there is no human interaction. Nah? When there is no human interaction, there is no use of lemmatization. Point is clear? Now, Venugopal is asking the question. Voice assistant in car comes under lemmatization then? Now tell me, Venugopal, in the voice assistant in the car, whatever you are saying to the car, it is giving the reply to you or it is not giving the reply and it is working automatically inside that? It is giving the reply now. Obviously, it is replying means it has to speak, right? Some words it has to speak. What are the words it is trying to speak? That words We have to understand, right? Clearly. So obviously lambdization. Point is clear? Okay, done. Shanti, slightly still little confusing. Please ask exactly what is the question and where you are getting confused so that I can clarify. Clear now? Done. So here, this is stemming versus lambdization. Now coming to the second one. So now let us see the one by one. First, we have to remove the punctuation marks. Yeah, Venugopal is asking the question. For example, robo vacuum cleaner is there. In that, we are going to provide the robot to ask to clean this corner or that one. Voice assistant. Using the voice assistant, you are doing that. Now, as per Venugopal, the question is whether it comes under stemming or lambdization. Everyone, please respond. Whether it comes under stemming or lambdization. Stem only, right? It will not respond outside. For example, if your robo is having the speaker, assume your robo is having the speaker and it says that at what time I have to clean yours. And if it is asking some questions to you, something, then point is clear. Perfect. Venugopal, your question is also clear now. Yeah, whatever you have told, that is correct answer only, basically. Done. So next, yeah, obviously ChatGPT is lambdization, huh? But particularly ChatGPT will not work in this case. ChatGPT is a different sequential order data, right? As I've told you, for sequential order data, the concept will be different. For non, this is non-sequential data. The concept will be different, right? Done. Now, test cleaning means, as I've told you, it's a combination of removing the punctuation marks, stop words, stemming, and lambdization. It's a combination of everything. Now, let us do this. Stemming and, for a given data, let us do three of them. So here, what I'm going to do is, I'm going to consider three sentences for our understanding. A small data set I'm considering. And what are the cleaning and data pre-processing, everything you are going to do, it should be done only on the input data, not on the output. It should be done only on the input. On the output, then what we have to do? On the output, we have to simply do only one thing called as label encoding because it is having the categories. It is a categorical variable. It is a part of the structured data categorical variable, whereas this one will be considered as input variables. So input variable here, it is not a structured data. It is a text data where it is having the sentences instead of words. Words are there means we call it as categories. But here not words are there. It is having the sentences. Point is clear? Done. Now let us take one small example. Here I'm going to take the example of this one. That is he is a good boy, dot. Full stop is there. To remove the punctuation, I have added the full stop extra. And next, she is a good girl, full stop. And boy and girl are good. Now I'm going to consider the only input column. I'm not going to consider the output column, only the input column. And based on the input column, we are going to execute this. Just a minute. Okay. The first one is cleaning. In the cleaning, what we are going to do, that is step 1. Remove the punctuation. Everyone please make a note of this examples clearly, as this is going to be important one. I want everyone to write in the notes clearly. Once done, please let me know so that I'll start explaining. Take the example, as this is one of the important one for the entire test classification, and in the ChatGPT also, in the further when I'm explaining the Gen AI project also, I'm going to use this project very multiple times. Done? Now, so here, first, what is the step 1? Remove the punctuation marks. Step 2 is remove the stop words. Third one is stemming or lemmatization. Total three of them we have to apply. Now I'm going to apply 3 of them in the sequential order one by one. And finally, I have to get the clean data. Okay, the input data has to be cleaned, right? Now first, here let us take the example 1. He is a good boy. Okay, dot. In this entire one, I want to remove the punctuation. Punctuation means what? Only the dot. This will be removed. In the entire given sentence, punctuation mark is this one only. In this record, first I'll take the record 1. As we know, for loop will be applied, and once we know how to apply for the single record, same logic will be applied on the multiple records. Logic will remain same. Right? Now, he is a good boy, dot. Second, we have to remove the stop words. So what are the stop words are there here? Miss, if you observe clearly, here all the stop words, what are the list of stop words are there? Every stop word is a small letter only. None of them is in the caps lock. Here he is a stop word, but which he, small letter he, not the caps lock he. So first what I have to do is, I have to convert everything to the small letters like this. This is the second step which I have to do. Okay. Now, so after converting everything into the smaller case, sir, there is a bad in stop boy, sir. Same logic. Logic will remain same only, no? What are the word it is? No, sir, in the program. Oh, here bad is there. Okay, okay. Okay, let me write here. Sorry, my mistake then. Good boy. She is a good girl. Boy, girl are good. Okay, first one is he is a good boy. Dot. He is a good. Next, I have converted everything to lowercase. Since it is a string, I have applied the string dot lower. Simply, I will apply the string dot lower, and this will be converted to string like this. After string dot lower, I will apply the split function. Once I apply the split function, automatically words I'm going to get. He is a good boy. Okay, good boy. Now I'm going to get like this, right? Now, once I apply the split, the words are, once I get the words, what are the words are available? Now these words, what if multiple sentences? And if you remove the punctuations, then it will be a huge corpus. How we can handle the multiple sentences? That one we are going to understand. Bharat, wait for another few minutes, you'll understand. Okay, next split. After the split, here I'm going to remove the stop words. Remove stop. Within this, what are the stop words are there? We are going to remove the stop words. So what are the stop words? He is a stop word, remove. Is a stop word, remove. A is a stop word, remove. Good is not a stop word. So good will be there. Boy is not a stop word. So boy also will be there. After removing the stop words, now I am going to apply the stemming. What are the balance is there? For the balance words, after removing the stop words, what are the balance words are there? For that, I will apply the stemming. For the good boy, good only is the stem word. For boy, boy only is the stem word. So both of them. Then finally, what I'm going to do is string dot join. I'm going to apply the join function. That is, we are going to join them by using the space of yes. Now automatically it will be converted to a single string like this as a good boy. So finally, okay, starting from the he is a good boy dot to, this is the starting to, finally you are going to get like this, good boy. The output we are going to get as a good boy. Okay, starting from the he is a good boy to finally good boy. Right? So in this, first we are going to convert everything to log. First, remove the punctuations. What are the string is there? First, remove the punctuation. That is the first one. Later, convert to lowercase. Later, do the split. Then remove the stop words. Then apply the stemming. Then again join the words. Finally, you'll be left with the cleaned sentence. Okay, what are the clean sentences there? Just you are going to have the clean sentence like this. Now see here. First, I'm going to take for I in range of length of df. Here, what is the length of df? Means total 3 sentences are there. Sentence 1, sentence 2, sentence 3. Total length of 3. Range of 3. What is range of 3? Means 0, 1, 2. So here first I'm going to take the df of input of I. What is df of input of I? Means within the df, this is the one input column. And in the input column, first I'm going to consider the 0, followed by 1, followed by 2. So 1 means nothing but he is a good boy. For he is a good boy, here I'm going to use the import RE. RE means regular expression. That is the module name. Regular expression. So here I'm going to use the regular expression module, RE module. And from that RE module, I'm going to here subtract. Okay, sub. I'm going to remove the other than small letter A to Z, caps lock A to Z. Other than. This symbol indicates other than. So other than small A to Z to caps lock A to Z, other than this, and along with the space. Apart from this, remove everything. So here what I'm going to do is, to understand this one, I'm going to show you sentence, code to code. What happens in the each code. Okay. Now, corpus dot append of RP. RP is some variable name. Okay. Print corpus. What are the corpus is there? Just I'm trying to print the corpus. Can you see? First, wherever the small, other than small a to caps lock, small a to z to caps lock a to z, whatever we are having, this one, other than this one, everything are replaced with the space. I have substituted with the space. Okay. So here, next, Shanti is asking, what is corpus? Corpus is nothing but as some variable name. If you are interested, you can choose any other variable name, list. Example purpose. as of now. Okay, I'll explain in the further what is corpus. Okay, now, so here first I'm going to take the sentence, first sentence, that is he is a good boy, or directly I'm writing here 0 only. What is 0? No need of even for loop also. Let me remove the for loop. Automatically, once we know for one of the sentence, same logic will be applied on the every sentence. See, he is a good boy. Whatever the dot is there, the dot was replaced with the space. So other than A to Z to small a to Z and caps lock A to Z, other than everything has to be replaced, substituted. SUB means substitute. It has to be substituted with the space. It will be substituted with the space. Next, second step, what I'm going to do is, I'm going to convert everything to lowercase. See, instead of caps lock HE, now it was converted to lowercase. First one is remove the punctuation. After that, I have converted to lowercase. After converting to lowercase, I am applying the splitter. So automatically, I am going to get he is a good boy. Separately. Now, next I am going to take the whichever the words are not in the stop words. Which words are not available in the stop words? Only those words I want. The words which are not in the stop word. Now, I'm going to write like this. Now, what is the words I'm getting the which are not in the stop words means good and boy. Now, I'm going to apply the stemming on these two words. What are the two words are there? Just I'm applying the stemming here itself. Directly ps.stem. PS means Potter stemmer. Already I have imported the Potter stemmer as PS. I have stored that one in the PS. So within the Potter stemmer, stem. So I'm applying the stemming. Now after applying the stemming, now this is the final word. Now after stemming was completed, now what I'm going to do? Join them. What is there? I'm going to join them. Now finally I got as the good boy. Is the point is clear? Everyone? One by one. Same logic will be applied for the second sentence. Same logic will be applied for the third sentence. One after one sentence. Is the point is clear? So remove the stop words. After that, you are going to remove the this words stop. To remove the stop words, as we require the lower along with the split. Both we require. Otherwise, we cannot remove them. And finally, we are going to join them. Now, same logic I'm going to apply here. And see, good boy, good girl. And here we are having the boy and girl are good. And is a symbol and dot is a symbol. So just I'm removing the symbols. And finally, good boy, good girl, boy, girl, good. Understood? Yes or no? Everyone, please confirm. If it is not clear, I will explain one more time. Clear now? Now, next, I'm going to do the vectorization. Bharat, yeah. Bharat, I have not still answered your question. You'll understand that question after this, after the vectorization was completed. Still your question is pending. I'll explain that. Yes, Dharmendra, 2 times I asked, but he didn't not do. He is bad. What in your sentence, 2 will be removed. Sir, but 2 also should be included. 2 is an important one. It has to be included for me, miss. Numbers are also important, miss. Then you have to write here 0 to 9. So other than a to small z, caps lock a to caps lock z, 0 to 9. Other than this, everything will be substituted with the space. Is the point is clear? Sir, is there any punctuation function or we have to use regex? We have to go with the regular expression only, regex only. There is not directly in the core Python, we are not having any function for removing the punctuation. Inbuilt is not available. Right? Done. Still any questions? Now, next one is vectorization. Explain the line after split. Here, Mayur, this line is nothing but for the word in RP, means after the split was completed. For example, here, you will get the after the split. Okay, what are the after the split? He is a good boy. Now, for word in RP, what is word in RP means what? This one only, na? For each word in the RP, take the first word. What are the first word is there? He. If not in the stop words, within the stop words, if it is not available, only that one has to be selected. Only that one has to be selected. The word which is not in the stop word, select the word. So I want the words which are not in the stop words within the RP. RP means this one in this variable. Right? And please don't ask what is RP. RP is a variable name. Maybe on that day when I'm explaining to the one of the student, I have used his name, Ravi Prakash or something would be, and I have used it as the RP. There is no meaning of RP or something. Okay. What are the variable name you are interested? Okay. Each time after execution, I'm storing it again in the same variable. The reason behind that is these are immutable data types. Immutable data types will not be stored automatically in the original data type. So automatically we have to store in the new variable, and the output should be stored in the new variable or existing variable. We have to write separately. It will not store in the default in the original object like list. If it is list means it is mutable, but it is not list now. Understood? Understood, guys? Now, next, vectorization. Now, what is meant by vectorization? Here, this point only more important. Please understand this one, as this is going to be the first step for our entire text processing in the future also. Now, here first I am going to use the count vectorization. What is meant by count vectorization means how many times it was repeated. Now, first tell me in the given words, how many unique words are there in the entire data? How many unique words are there? How many unique words? Three words. So what are the three words? And that to alphabetical order. I want the three words that to alphabetical order. Boy, girl, and good. Right? Done. So first boy, first column name, girl, second column name, and good, third column name. So total three columns it is going to take like this. So what are the unique values are there? For example, sir, 100 words are there, 100 columns. So 200 words are there, 200 columns. 10,000 words are there, 10,000 columns. 1 lakh words, 1 lakh columns. No restriction. Then automatically the more number of words, the bigger the size of the data, no sir. That is the problem, and how to reduce that one we are going to see next. But initially that we'll see. But in the entire data, even for 10,000, even 1 lakh words are there. Let's assume you have taken a huge amount of data. In that 1 lakh words are there. 1 lakh unique words are there. that 1 lakh unique words, how many columns will be created? Means 1 lakh columns will be created. 1 lakh. Literally 1 lakh columns will be created, right? Now, question is, what about the performance and how it will be, output, the generation of the output, what is the problems that we'll discuss, right? As of now, just it is going to create the 1 lakh columns if 1 lakh words are there. As for our data set, 3 words are there, 3 unique words are there. Okay, how many sentences are there? Forget. For example, instead of here, bad is there. Okay, not boy, bad is there. Automatically, how many columns will be created, guys? So columns are created based on the number of records, or columns are created based on the number of words. Columns are created based on the number of sentences, or words means based on the words, not on the sentences. Words. Okay, sentences might be only 2 sentences, but inside the 2 only 100 different words are there, also 100 columns will be created. Right? Now, in the first sentence, how many times the good is there? How many times? How many? How many times good is there? 1 time. How many times boy is there? 1 time. How many times girl is there? 0 times. Like this. Coming to the next one. How many times good is there? Again 1 time. Girl 1 time. Boy 0. This one. Boy, girl, good. How many times boy? 1. Girl 1. Good 1. So this is called as count vectorization because it is counting the number of values. The output is number of values. So here, 1 minute. Okay. Now, so here I'm going to consider the column name df of in. The column name is df of in. Now, automatically you're going to get the 101, 011, 111. Point is clear, guys? So, for example, assume here I'm having the sentence like this. Good, good boy. Okay, he is a good boy. Now, automatically after the data cleaning here, good boy is there. Now, how many unique words are there? Means same number of unique words. But in the first sentence, how many number of times good was repeated? How many number of times the good is there? So, 2 times. So, here 2. Sir, for example, good is 5 times, sir. 5. Count. Just it is count. You are going to get here 2. It is count. That is the reason it is called as count vectorization. No scaling. Sir, it is like zeros and ones. It will have only zeros and ones, miss. That is the reason I am showing you one more time good boy. You should not think otherwise you will think only zeros and ones will be there. Now, as one of the student is asking the question, what is the use of count? Now tell me guys, what is the use of count? Others respond. Leela is asking this question. Give other students please give the answer. What is the use of count? Numbers we can continue, we can convert the numbers to any numbers. Why exactly to the count only? What is the use of count? If you remember yesterday to calculate the probability, what we required? Count only, na? What we required? Count only, right? So for test classification project, and when we are going to apply the Naive Bayes theorem, what type of factorization we have to do, miss? Count only. right? Done. Just give me 1 minute. Done. So here, good boy. So that is the reason here you got the 2, right? It is called as count vectorization. So what is meant by count vectorization means just converting one sentence. This is the sentence. Sir, good boy. So since good boy is there, so we have converted as 102. It is a vector. 102 is a vector. Good girl was converted as a vector of 0, 1, 1. Whereas boy girl good was converted as girl good was converted as 1, 1, 1. Like this, it was converted. It is a vector. 3 of them are vectors. Now, for example, instead of good boy, boy good is there. Then also same vector only. Good boy good is there. Then also same vector only. Here, order of the words are not important. Huh? That is the main point, right? Order of the words are not important. What is important? How many times it was repeated within the one category? How many times it was repeated in the second category? How many times it was repeated in the each category only we required. Point is clear. We don't want the order of the words. Whether it is a good boy also, boy good also, still the answer will remain the same only. Is the point is clear, everyone? Understood? Yes or no? This is called as count vectorization. Now, second, now let us come to the main point. What is that main point is? In the starting itself, Bharat has asked this question. Later, some other students also asked the question. Okay, the question is what? Means if unique words, what are the unique words are there? If unique words are very high, since we have taken small data set here, it is very less. If unique words are very high, size of the data will be very huge. Size will be very huge. Then how to handle? Size will be huge. To solve this problem only, the solution for this one only, they came with the stemming. Stemming has reduced at least some of the words. For example, stemming is not there. Let's take stemming is not there. Then beautifully, beautiful, beauty. 3 different words will be created, right? At least by stemming, the words are reduced. That is the main advantage they have identified the stemming is same meaning words by unnecessarily 2 or 3 columns. That is the main purpose of stemming. That is the first main purpose. Okay. Second, how to handle with respect to more amount of data. For example, after applying the stemming also, still I got the 25,000 words are there after stemming. After stemming also 25,000 words are there. But 25,000 columns, if it is created, it is going to be a more complex data. Then what to do means, here we are going to restrict ourselves. by using the maximum futures is equal to, futures means columns. One column is called as one future in the machine learning. In the general, we call it as column. In the statistics, we call it as variable. Each column is called as variable. And in machine learning, we call it as future. Already I told you earlier. So we are going to restrict the maximum number of futures to some limited of 5,000. Means only 5,000 rows, words only has to be considered. Even if you have given the 10 million unique words is there also, I want only the 5,000 words. So this is the two solutions which they have brought. Now, sir, by using the stemming or lambdization, whether accuracy impacts means that we have to try. In one data set, it may not have impact. In one data set, it may have more impact. Stemming will not have that much of impact. Okay, this is not having that much of impact, though that is the reason blindly we will apply the stemming. But whereas, why only 5,000? Why we can't take the 6,000 or 7,000? Means it is tuning. It is not a fixed value. So we are going to try with the 5,000. For example, with the 5,000 columns, 5,000 input columns are there. Columns only 5,000. Forget about the rows. Columns only 5,000 are there along with the output column. So 5,000 columns of input are there. Now with this 5,000, I got the 95% accuracy. Let's take an example. By 6,000 columns, okay, 6,000 words, I got 95.2. Now tell me whether you will consider the 5,000 or 6,000. For example, with 4,000, with the 4,000 only, you got the 95.4. Now, in this case, with the 3,000 words only, you got 98. Now, in this case, so at this R, for example, here you got the 88. This is 88. Now, overall, you have got like this. Which one you are going to consider? So, point is tuning. So, for the given data set, which words are, how many words by considering it would be correct, according to that it will do. Everything is clear now? Bharat, is your question is clear now? I told I'll explain later now. Yes. Others? Now, yes, that is again good question. Out of 25 words, which 4,000 only? Which 4,000 will be considered? And what about the remaining data? See, in the given data set, assume structured data set. Forget about that, this one also, structured data set. For example, input data consists of 50 columns. They have given to us 50 columns input data. Now, in that 50 columns input data also, assume out of 50 columns input data, we have removed the unimportant columns, which are not important that much. 40 columns you have removed also. Is there any problem? You are proving, literally you are proving that there is no use. For example, in the entire data set, like in the this one also, in the text data also, assume total rows or total like sentences. Okay, like here, how many records are there? 3 records only. Na? Like that, I'm having the records only 10 million are there. 10 million records. Records only 10 million. In that, out of 10 million, one particular word was repeated only in one sentence. Means every case it is 0, 0, 0, 0, 0. Only for one of the sentence it is having one, but everything is 0. Only one sentence out of 10 million records, one record only is having. Now tell me, that word should I consider or should I ignore? Jahnavi. Now it is clear before you are asking the question now. So now the words, so see here, for each word, out of each word, for example, some words will be there. Let's assume. Okay, forget about the sentences. Here word 1, word 2, word 3, word 4, word 5, 6. 5, 6, 7, 8, 9, 10. 10 words are there. In this particular first word, in the sentence one was repeated 2 times. Second sentence, 0. I mean, second record. Sentence means my meaning is record, complete record. Okay. Next one is 3. Next one is again 0, 0, 0, again 1, again 0. Okay. Now total in the oral records, how many times this word is there? Total. Total, can we calculate total? Like that for every word we can calculate the total? Yes or no? Total for every word. Now in this, I want to select the top 6. Can't we select which are the top 6 words? Yes or no? So in the code, within the Python code, okay, inside the Python code, here we are going to restrict. Okay. For example, if I taken this data set, total 5,572 records are there. Now, when I have done this one, total number of words itself I have got approximately 7,000 words are there. Overall, in the entire data, 7,000 words are there. Now, what I'm going to do means, here within the naive Bayes theorem, I'm going to write the max futures. Max futures is equal to 5,000. Now, whichever the top 5,000 is there, that will be selected. Top 5,000. Point is clear? Everyone. So, for example, here 10 words are there and multiple sentences are there, but words are only 10. Can't I select the top 6 words? Means the words which are repeated in the more number of sentences. Can't we select that one? Manually. So, nothing but doing the sum of this column and after that applying the sort on this. And in this sort, which are the slicing operation, that is top 6 separated. Only those words are selected. That is the complete internal backend code of this. Jahnavi, is that clear? Yes or no? Done. Prasad. Next, Prasad is asking the question. When we give limit of 5,000, that is choose the random columns out of 25, or now it is clear now? Your question also, Prasad. Vidyasagar. But top 6 cannot describe all the sentences. We may miss some sentences. Yes. Now, for example, the accuracy remains same for the 10 words also and for 6 words also, if the accuracy remains same. Then, if accuracy differs, obviously we have to go with the 10 out of 10 only. There is no other option. Clear, guys? Understood? Till the vectorization. Now let us do the 2 projects. One is called as test classification project. Second one is test clustering project. 2 projects we have to do based on this. For 2 of them, the text cleaning remains same. Vectorization also remains same. Because both of them common is unsequential data. So let us do the unsequential data for both of them. Where the words order is not important for us. That word was repeated in which category, how many times only is important. But we don't want what is the meaning of that word. For example, there is one word called as HUUUUN. That is a word. Don't ask what is the meaning. That is a word. Now my question is, this word was spammer hammer. Means, sir, how many times was repeated in the spam, sir? How many times it was repeated in the inbox? Simple. Sir, but that word is not having the meaning now. I'm not asking the meaning, right? Did I ask what is the meaning of this word? That is our project. Our project is not the meaning of the word, right? Our project is what? Classify whether it belongs to spam or ham. Now, if the stemming output of the stemming is given as the some new word, that word existing only is not there. We don't want the meaning of that. We only want how many times it was repeated within the span, how many times it was repeated within the ham. That's it. Anyone knows what is the meaning of this word? Basically, I don't know. In a flow, I have written something or HWSK something. After stemming, you got the output like this. We don't want. Same. Just we want how many times repeated in the each category. We want the probability only. Based on the probability, we'll predict for the future data. Simple. Right, guys? So in the next class, we are going to complete the two projects related to unsequential data. With that, this one also will be completed. Then we can move on to the sequential text data. That is next one. Everyone is done? If no questions, we'll end up with this and we'll continue in the tomorrow's class. And we are also having another type of factorization, but another type of factorization is having another importance. But this non-sequential text data, we are having only this one. This count factorization with the cleaning water I have told you. The different project, different application. In that case, it is going to be different. Next, tomorrow we are having the ML class at 6 p.m. As usual. As I've told you, tomorrow we'll have the ML class at 6 p.m. and the link will be shared in the classroom. Please go through the previous class once. The continuation of the previous class. What we are discussing in the previous class, that is regression regression we are discussing now. The same thing will be continued with the balance algorithms of regression. ML class. Okay, yours and other batch students also will be joining. 6 p.m. ML class and 6 to, as we know, it will be extended up to 8 or 9 based on the topic length and everything. And second, most importantly, link will be shared in the classroom. Link will be, don't go with the normal one. Link will be available in Google Classroom. You will get the link in the classroom. Use that link and join. And Monday is holiday or not holiday. Tomorrow we'll discuss. Tomorrow we'll attend, right? Because as of now, I'm not also having the information. 99% there'll be no holiday. That too, our classes are in the evening hours now. Mostly 99% no holiday. As Morley also says that please don't take any kind of leaves or holidays or anything. So 99.99999% no holiday. Right? Done. Done, guys. That is the end of the session and I'm going to upload the notes. Please go through and we'll continue in the next class. Thank you. Take care.